The main reason why we would practice computational thinking here is to solve problems, big problems. That's what computers exist for, that's what technology is around for, is to make our lives easier to solve the problems that we have. These four pillars, there is not necessarily an order to these four things, but throughout the computational thinking process, these four things come up over and over again. The four pillars of computational thinking here are decomposition, breaking things down, like I said. If we have a hugely complex issue, then we want to be able to break it down into smaller chunks in order to solve problems that are within that issue. So larger issues have subcomponents that we can identify, and it makes the problem a lot easier when we can solve these little problems rather than trying to think about the larger problem and get overwhelmed. We're going to break things down into very small components where we can take things on one at a time. In that process is abstraction. It's turning something that is very real into a visual model that we can use to our advantage in solving this problem. An example might be, we'll explore flowcharts here in just a little while. If we have a process that we know and we're very familiar with, but we're trying to identify where in the process something is messed up, then having a visual model of it will allow us to just kind of be like, oh, there it is, it's right there. It really helps us in the problem-solving process, that method of abstraction. Another one that is hugely important is pattern recognition. If we have tons of data, if there's tons of information out there, then being able to spot the pattern within this data is naturally a part of the problem-solving process. And finally, and not most importantly, but maybe most importantly, is the process of algorithmic thinking here, which sounds super fancy, but it's not. It's just following a certain process. And sometimes there are splits in that process saying, if this happens, then we go down this road. If this happens, we go down that road. A few subtleties to algorithms, but it's literally like, think of a recipe. Get these things together and then do this, 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 and this. That's your algorithm for a successful bundt cake, etc. So these are the four kind of skills that we're going to get into here. And like I said, I could talk about these all day. And these are not necessarily the only things involved in computational thinking, but these are the four big ones. And rather than continuing to talk, I'm going to pass out some stickies, and we're going to jump right into solving a problem here at Resurgence. Computational thinking.
Yeah. Is that like the overall theme in computer science today?
Yes. So underlying virtually all of computer science, which again exists to solve problems, is computational thinking, and often what companies are looking for are not necessarily, can you code in Python? But they're looking for, how you think? Can you solve problems? Can you learn quickly and in different ways? We are going to identify as many problems as possible, but we're not going to call them problems, we're calling them opportunities.
Yes.
Of course. So what I want you to do, I'm going to posit this question, and I'm going to put 2 minutes on the clock, and I want you to write down as many things as come to your mind as possible. And we're going to end up with a lot of opportunities here, one on each Post-it note, so that we can see them visually up here. What are the hardest parts of working at Resurgence Hall? Here are opportunities.
I know. I mean, that's what I'm constantly thinking about. What do we do better? That's just how my brain works.
Let's see, the first one is not enough time, and I see another not enough hours in the day here. So follow along with me. I'm going to go ahead and kind of group these together in different areas so that we're kind of recognizing some patterns here. So yes, all of these are our opportunities here. And what we would do from here is pick a problem that we want to focus on. In an interesting way, there is some overlap between our pattern recognition skill here, abstraction. This is kind of a model of all of our opportunities. Decomposition, we definitely kind of broke some things down here already, so we're seeing these themes come up quite a bit already. It's just time in general. There's not enough time. Okay, good. That can be our problem statement, not enough time. I'll say that we mostly just practice some pattern recognition here to identify this problem. What I want to do now is, this is a huge problem, and we need to break it down quite a bit. So what I am going to do is kind of give an example of a way we can break it down, and then I want you all's feedback on if I'm breaking it down in the right ways, or if there are other components to the time thing that we could kind of add to our abstraction of the problem here.
Or whatever, but then it's like, before that we're doing emails, or we're doing,
Okay, so this is a good first breakdown of the time issue here. We just decomposed this big time problem into a bunch of smaller problems, smaller areas that we can now zoom into even further to get into this. And I'm wondering if we can break down Workday a little bit further. And if we need to, we can go into deliverables a little bit more. How could we decompose your Workday?
What do you mean?
I
know you mean like break it down, but
like what components?
Scholar time.
Okay, so there's.
Before they come.
Gotcha.
Like there's that time.
Okay, and what do we call that time?
I'll just say
Pre-scholar, okay.
Pre-scholar.
Gotcha. Pre-scholar time.
then scholar.
They show up. Okay.
Yeah,
They're here.
It's scholar time.
7:30 on the dot.
7:30.
Scholar time at 7:30.
Do you want to break that into like time chunks? So like that would be like
In the morning,
7:30, and then they're on until 10:55, then to 12:55 till 1. They're
So,
on
like-
until 1. From 7:30 until 1.
Yeah.
Yeah, 7:31.
Y'all are like
Teaching.
active
Yeah.
that whole time. Okay. Yes.
And then
And then it's like 30 minutes.
Great. This is a pretty solid breakdown of what we need to do. And usually what ends up happening with this is you keep on realizing there are more levels to the decomposition thing. I really don't want to take too much time out of this, but it might even be good for us to break down kind of the use of time within one of these areas to see if, like, I don't know, can eating go in prep? Or, that's not realistic, but just some examples of where are there kind of opportunities for a shift. But this is now an abstraction. We virtually made a timeline of our day here that we can start to see and manipulate to break down what we have here. Some other examples of abstractions might be graphs, charts, little drawings of them even. Have you seen those like mind maps of like things, concepts that are connected in various ways? Your like LinkedIn network is an abstraction of all the people you know, etc. So we can kind of cruise right through the abstraction process of this because we already have it here. We have a lot of perspectives in the room, and I'm not going to come up with solutions for y'all. I don't know exactly what's going on in your life. You all are the experts of this. So what I want to do here is have you all do another kind of brainstorming sticky note activity in which we are generating potential solutions. What might work here? Knowing that it's with this visual of the abstraction as kind of a guide in this process, and knowing what you all know about your work environment, Now we have a ton of solutions here that we'll definitely keep track of and see which ones might really save us some time throughout this. For now, I want us to pick one.
Yeah, it's
I
Not
understand,
enough
because you
time.
have to be here longer than us.
No, I'm with, no, it's not about that, it's
That's
just,
just-
I think, and what I've had so many talks about this with other people, like, it's the profession. I do think there are certain things here that, yes, we need to better work through, and we're building the plane while we fly it type thing. But I also, like, spoiler alert, this has been my work life, or my pace for the past 9 years.
But then I'm wondering, like, because sometimes I think, like, I go home and I'm like, I'm not even, I mean, yes, I don't know, like, sometimes I'm like, I'm not a full-time teacher, but like I am, but I don't feel like I have nearly the amount of prep or anything like they do. And I'm like, how am I staying here until they do? Am I not using my time wisely enough? And then I'm like, well, no, I couldn't do it because I was in a meeting and they didn't have one. So like, which then I'm like, okay, also I feel like I'm in a fellow position because like I am trying to grow more. So like I want that like push all the time, but then it's like, I feel like I shouldn't.
So if, I have a question, if this were eliminated,
Well,
this is
which
the
one?
after school, this
Or
is,
just
let's
one-
say,
Just one day.
One day.
One day,
okay, let's stick with one, it would help
one, not
tremendously,
two,
yes.
not the one.
That one was taken away, it would be a game changer.
Yeah.
The algorithm for that would look like take away one meeting per week and take away one pod per week, right? That's basically where we're at with that one. So I'd love to explore the email one real quick and just build an algorithm in a kind of flowchart style right up here. If y'all want to kind of follow along with me, and feel free if you want to take a seat, then we can kind of run through and see that, and then we'll leave here with two solutions, which is pretty efficient, time efficient. So this whole less emails solution is really very possible. And what we want to do here is come up with kind of a step-by-step process on how to reduce these emails. And Paige and I were actually talking about a program called Slack. Have y'all heard of Slack?
Yes,
Yes.
yes. I can't remember
You've
what
seen
school I did it with, but yes, I've heard it.
Cool. Yeah, so it's something we use in the tech companies use it quite frequently. Coders use it a lot. Startup community is very fond of Slack. What it basically does is it's a program separate from your email that houses communication. But this is an example of a flowchart, and we're going to replicate this for implementing this email solution here. So the first step would be, as Paige mentioned, to prototype with 7th grade. So this is step one right here. Now, what happens from there is a big conditional thing. If it works for 7th grade, then maybe it would be useful in the whole school. If not, then we go a different direction on the flowchart here. So you'll usually see these as diamonds for these if statements. Works. And expand use. So once you have the kind of training and it's integrated with other channels, if it's really saving you all time, then mission accomplished, right? If it doesn't, then you kind of have to reassess. No time saved. And then another thing, aside from a conditional statement, an if-then statement, another thing in computing is often a loop. What we would do is jump back up here. And there may be other solutions within this along the way, of course, but this is more or less the algorithm for saving you all time with emails. This is literally a program. This is a script. Say we built a robot to teach for you all, then what we could do is code this into that robot for it to keep on iterating on this until it learns to save time with this. So why I'm bringing this up, this is algorithmic thinking. It's simply coming up with the steps and putting it into an abstraction, then after having broken it down and finding some patterns. There may be some pattern recognition that happens in sharing best practices, like, oh, we use it in this, and this way, and it saves us time. Okay, let's all try that, and then we get to mission accomplished. Yeah.
So I'm thinking about seventh grade. They were sixth grade last year. This is exactly what they did when we had introduction to JavaScript, but specifically when they made games, they had to create their conditionals to create games. To lose lives, for example, if character goes off screen, then life lost. If character gains apple, then add 10 points to counter. And I noticed the scholars that had this type of thinking and our other design thinking processes or other areas that they had that already in their head were able to more successfully code as a result of this type of thinking. So I'm thinking through in kindergarten and first grade by teaching our kids how to think this way, we are setting them up for success when they learn the physical coding components of computer science because they'll have that thinking.
So, you've been heard. I went to Tori.
That quick?
She was literally walking down the hallway, about to go home while we were outside.
No more meetings on Tuesdays and Thursdays after school. We will work together to make sure that any information that was being shared or taken care of during that time does still need to happen during our pod time. And moving forward, we can think about how that pod time is spent and remove unnecessary things as we go.
So,
Yay!